Hi, Roku Developer. If you're just starting your Roku Dev journey and looking for best practices to follow, or if you're an experienced developer looking to review the basics with a modern twist, this keynote is for you. My name is Arturo, and I'm the lead Roku developer at Haystack News, where every month we serve a personalized newscast experience for millions of users. Today, I'm here to teach you everything you need to know to go from zero to production in Roku, using best practices and open source power tools that will 10x your development experience. The first step to go from zero to production is to start with a modern project structure. For this, we'll use a tool called Create Roku App. Run it with npx and follow the steps that are presented to use modern language features, declare a code style guideline using a linter and a formatter, enable an advanced DOM inspector that comes embedded in your code editor, and install all the dependencies needed for the features mentioned. Once our project is ready, we can open it with VS Code. As you can see, Create Roku App includes everything you need to bundle and run your application with one click. The only thing necessary is to add our device credentials in the vsconfig.json file. Now, press the F5 key in your keyboard to launch your application. If everything went correctly, you should see a simple screen like this. This Hello World message comes from the main scene component, which is set to have a label in the XML part and the text of that label in the .bs part. In Roku, UI components are usually conformed by an XML file and a .brs file, but in this case, we will use .bs files, which means that we are writing our application logic in BrightersScript. BrightersScript is a superset of the BrightScript language, which allows us to use cool and modern language features like classes, enums, syntax sugar, and many more. Now that we have our basic Roku application running, let's take a look at the application that we will build today. I present to you Midnight Binge, your new favorite hub for all kinds of blockbuster movies. Midnight Binge allows you to select your favorite category, scroll through your movies, and start playing your next binging session. But before we get too excited, let's remember that we are about to start from zero. So let's go back to our blank project and start talking about the basics of creating interactive UIs. As I mentioned before, components have an XML definition, which is useful for defining the visuals and attributes of our components. Here, we are defining a custom component that extends from a scene component. Scene is one of the multiple native components that are part of the SceneGraph UI framework. The scene component has many fields that we can manipulate to change its appearance and behavior. One of them is the background color field, which we'll use to paint a fancier dark background. Now that we have it, let's create some UI components. If we see our final product again, you'll notice that it's mostly a bunch of images, labels, and buttons. Mastering these components will allow you to create 90% of Roku applications. Let's start with a simple image for our logo. First, let's remove the initial Hello World code to start from a blank slate. Then, we will add a poster component to our XML and define its URL, size, and position. Similar to how we can create UI elements using XML, we can also do so programmatically with the createChild method. Now we will use another native UI element called button group for our vertical list of categories, which for now will be a fixed list. And since we're using BrightersScript, we can define our categories in an enum and then set the buttons of the group with it. The button group component can handle the navigation between its elements automatically. But if you launch the application and press the arrows in your remote, you will see that nothing is happening. This is because first we need to set the application focus to the group itself. And now it works. Now let's create the list of thumbnails for each category. We will start with a single element. The basic container element in Roku applications is a group component. Think of it as a div in HTML. Inside the container, we should add our poster. We should also add a low opacity rectangle to show something to the user while the image loads. Notice that the order in which you define your components determines which one will be placed first. So here, the poster is actually on top of the rectangle, but it won't be visible until the image loads. We will also create a couple of labels for the movie title and director, and a poster to show a still frame of the movie. Before we continue, let me explain how the position of certain elements work in a Roku application. The elements that are a direct child of the scene are positioned in X and Y pixels from the top left corner of the screen, but the elements that are inside other elements take the top left corner of their parent as the origin, meaning that these coordinates are not from the corner of the screen, but from the translation of the parent itself. Now that you understand the basic rules of UI components, let's take a look at how a production Roku team would debug their application visuals. Have you noticed that our logo is not properly aligned with the menu? Usually, to find the sweet spot, we would change values until it looks right. But today, we will learn a better way to iterate the visuals of our application. Notice that every time you run your Roku application, the Run and Debug panel opens. It contains multiple sections that are here to make our lives easier. The first one we will explore is the Scene Graph Inspector. When extended, it shows us a tree view of the components of our application. We can use the quick access controls to go to the currently focused node, move a node around, and toggle its visibility. If we click the pencil button, we can access a more detailed view of each of the fields of the node and change them in real time. For example, we can change the translation values and copy them to our code once we find the sweet spot. In the case where you are exploring a more complex application or a code base that is new to you, it might be harder than this to find what you're looking for. That's why the amazing people at the Roku community also created the Roku Device View panel. Together with the Scene Graph Inspector, you can point and click to the visual element that you're looking for and find it. Now, let's wrap up the basic UI of our application. We cannot have empty categories and a single dummy thumbnail. Our goal is to load a different list of thumbnails per category and be able to change the movie description by hovering between the elements. So, how do we get there? Let's create our list of thumbnails first. The first step is encapsulating our thumbnail visuals in a separate component. So instead of having a single thumbnail, we will create a new component that extends from the group node and contains the poster inside. With this ready, we can use a row list element to define a collection of items that are themselves defined by our new component. We will also need to set a few more fields that describe the visual characteristics of our list, like item size for the dimensions of each row, row item size for the dimensions of each element, row item spacing to define the space between each element of the list, and row focus animation style to define the animation that plays when we hover between elements. By doing this, our list is ready to showcase our thumbnails. But if you refresh the application, you'll notice that there is nothing in the screen. This is because while our list is correctly configured, it has no content yet. So let's see a basic example of how we can add elements to our list. If we go to our main scene file, we can refer to our list component by ID. We will create a new variable to hold the content, populate it, and insert it into the list. To better understand this, we need to know that the content of our row list is a 2D matrix of content node elements, each of them representing the rows and items of our content. Since our content is not a regular array, we cannot use something like push to add elements to it. Instead, we will use the createChild method to create our rows and items. By the way, the fact that scene is a component that can use createChild to add subelements, and content node is a component that can do the same, is explained by the fact that the SceneGraph library is composed of renderable and non-renderable components. With that said, now that our list is populated, if we refresh our application, we can see that 5 dummy elements have been created. But if we try to interact with them, we'll see that apart from our category list, our application is completely static. So let's fix that. Adding the code to move between our categories and our thumbnails is easy. Whenever we want to control what happens when the user presses a remote button, we need to implement a special function called onKeyEvent. This function receives two parameters: key, which indicates which key emitted the event, and pressed, which indicates if the event happened because of a key press or a key release. Our function should return a boolean, which indicates if the current component handled the key event or not. In our case, we only want to handle the left and right key presses. First, we start by ignoring all events that are not key presses. Then, the logic is simple. If we press right, we want to focus the list of thumbnails, and if we press left, we want to focus the category list. To reference these elements, we could use the findNode function again, but we could also set the existing variables we created on init to be in the scope of the whole component by prefixing them with m. This will make them referable outside of the method that created them, similar to how the keyword this works in other languages. And in case you are wondering, the special m.top variable refers to the SceneGraph component itself, which in this case is the main scene. This is why m.top_findNode lets us find children elements inside our main scene. So let's try our application now. But when we run our application and press the right button, we can see that an exception has happened. And this is the perfect opportunity to continue exploring the debugging capabilities of our modern setup. If we take a look at the Run and Debug panel, we'll see that we also have different sections for debugging the logic and flow of our application. The variable section includes the values of our variables at the moment of the exception. We can see all the variables that exist inside our current function, the ones at the m scope, and also the ones at the m.top scope, which refers to our main scene component. The call stack section tells us exactly on what file, line, and method our application crashed. In more complex flows, we can see from top to bottom the method calls that were traversed to get to the crash. The watch panel allows us to run arbitrary code each time our application stops. For example, we can check our first row and the number of elements it has. With that said, you should always remember that the most important step of debugging a problem is actually reading the error, because none of the information here would help us solve the fact that we have a typo in our code. The method we need to use is actually called setFocus. And with that fix, our application works as expected. Similar to our list of categories, once the focus is set in the list of thumbnails, the native component can handle changing the focus between the elements of the list. But how do we go from this to this? Before we implement the final features of our application, it's time we get ourselves some real data. I'm not going to lie to you, making HTTP requests with the standard library provided by Roku is really complicated and not beginner-friendly at all. So instead, we will use a modern tool that is maintained by the Roku Developer community, one that I can personally vouch for since I've been using it in production for a long time now. It's called Roku Requests, and it allows you to execute a simple request like this. But before we get there, how do we even install a Roku library? Well, the good people from the Roku community have implemented a package manager based on NPM to manage installing and updating Roku libraries. This tool is called RoPM, and you can install it with the following command. With our package manager setup, we can use it to install the request library like so. This command will install the files inside a subfolder in the source directory, which will be git ignored by default thanks to the configuration set by Create Roku App. As you can see, the methods in our install library have prefixes in their names. These prefixes are added by RoPM to avoid any naming collisions with the existing methods of our project. Now we have everything we need to make a request with a single line of code. But before we do that, here comes a very important concept. Making requests to a server is a costly operation with an undetermined amount of time for completion. Since our rendering logic is sequential, we cannot make requests here, because it would freeze our application completely until the request finishes. To solve this, we need to create a new kind of component to handle asynchronous operations. This component is called a task. We need to define an input and an output for our task. The input will be the category and the output will be a populated content node for our row list. The first thing we need to define in our task is what function will be run when the task starts. We'll call this execute, but it can be any function in the component scope. Now we can import our library with the import statement from WriterScript. We can also use a WriterScript const to define a constant string for the endpoint. Then, using the library, we will do a GET request that considers a timeout of 1 second and catches the response every time. With the response, we need to populate our content node similar to how we did before, but now with real data. We need to create a content node to hold our set of rows, a single row inside of that, and a content node for each of the elements of the row. In our specific case, we can use the input field to filter the movies for that specific category. Finally, we need to set the output field. This is our happy path, but it will also be wise to consider what happens if the response is not 200 or if the category we're looking for is empty. In both cases, we can return an empty content node. Now that we have our task set up, we can get rid of the dummy data creation. Let's create a new function that will take a category parameter and run our task with that category as the input. Since the task is asynchronous, we cannot just take the output directly. Instead, we have to wait for the output value to be set using an observer. Once the data is ready, we can take the output content node from the task and use it to populate the list of thumbnails. Of course, even with our row list now populated with real data, each of our thumbnails are still showing a static image. For performance reasons, the row list native component will determine the right moment to set the information for each of its elements, so that the whole list is not loaded all at once. So, in order to react to this event, we need to extend our thumbnail component interface with a special field called item content. Then, in the script of our component, we need to wait for this field to be set with an observer, and once it's ready, render the right thumbnail URL based on the data from it. Same as we just did for the thumbnails, we need to start using the data from each content node to render the movie showcase. Since we'll have to do this every time we hover on a different thumbnail, let's separate that into a different function that takes a movie content node and sets the appropriate label text and the image URL. By default, we will render the showcase for the first movie after the list has loaded. To render a different showcase for every thumbnail, we simply need to observe the row item focus field from our thumbnail list. The observer handler will take the content node from the focused item and render its showcase. And last but not least, to load a different list of movies for each category, we need to observe the button focus field from our category button group. Take the category from the button, which is the same as the button text, and load that category. And there we have it. We now have our full application UI. But before we go to production, there is a final technical aspect that we can improve. As you can see, we have heavily relied on observers and callbacks to handle our asynchronous operations. While this is convenient, in the long term, this pattern can become problematic for three reasons. First, you are forced to define single-use methods that are not meant to be run by anyone else, but can. I assure you that someday someone will come and call this method just because it's possible, and your application will break. The second reason is that your callback methods eventually get further and further away from their original callers. It's very easy to just add more and more methods until eventually you lose context of where the caller of your function is, especially because the observer handlers are not invoked regularly with parentheses. For this same reason, if you introduce a bug in one of your callbacks, debugging what observer triggered it can become difficult, since the stack trace starts at the callback, not at the observer. To solve these problems, we can use an open source library called Promises, which introduces a new and better way to handle asynchronous operations. By providing an onDone method to immediately define our callback functions. To install it, run the following command. In our task, instead of having input and output fields, we will have a function that takes the category and returns a promise. This function will create a new promise save the category in the component scope, run the task, and return the promise. In our execute method, we have to start using our new category variable and resolve the promise instead of setting the output field. Now, in our main scene component, we can get rid of the code that would normally start a task manually and receive the created promise instead. Then, we use the onThen method from the promises library to set up an inline callback where the output will be passed when the promise is resolved. By using this, we can get rid of the extra method that handles the task output and keep the task start logic together with the callback in a way that is more readable and easier to debug. And there we have it, our application is ready. We can now go to production. Before we do this, we need to make sure we have all the application visual assets ready. These images and their expected sizes are defined in our manifest file. With that said, we are ready to go to production. Unfortunately, we cannot just upload the zip that we have been using to sideload the application to our device. It would be completely insecure because it contains our full source code inside. Instead, we need to sign and encrypt our application code to a format that only Roku devices can decode. The first time we do this, we will need to generate credentials to sign our package. To do this, run the following command. And then enter the Genki command. Make sure to save these credentials in a safe place, as you will need them in the future to upgrade your production application from version 1 to version 2. Now that we have our signing credentials, to generate a signed package for the first time, go to your Roku IP in the browser, which you can easily find from the VS Code VRS panel. Go to the Packager tab and enter the name of your application and your signing password. Then, press Package. After just a second, you should see a link appear above the form. Click it to download your signed and packaged application. To publish your packaged application, you can go to the developer dashboard and click on the Beta Channels option. Then click on Create Beta Channel. A beta channel is like a pre-release version of your application. The process of creating it is almost the same as creating a real production application. And nowadays, this process is as easy as filling a to-do list. The parts of this list that might be confusing are the listing setup, which need you to declare the age rate of your application, and the monetization section, where you should just select that you won't monetize your channel. The channel package section is where you will upload your channel package. If this is the first time you do this, you should leave the channel version and minimal supported software as it is. After uploading your application, the Roku dashboard will run some automated tests in your application to make sure that it is compliant with the Roku certification criteria. Once again, Create Roku App takes care of including the code necessary to pass these tests, so you don't need to worry about it. With all the forms filled, the Publish button should become unlocked at the top right of your corner. Click it, and after a brief moment, you should see a toast saying Channel Published. To install your beta channel in any Roku device, simply click the link under Access Code. After saying yes to all these steps, the beta channel should appear in your device channel list. Thank you for joining me today. We just took a quick tour from zero to production in under 30 minutes. For those of you with some experience in Roku development, I hope you discovered new tools and insights to enhance your work. And for those who are just getting started, if some of these concepts seem a bit overwhelming, don't worry, that's completely normal. You can visit the link that is appearing on the screen to find the source code of our application and step-by-step instructions on how to recreate it, along with reference links to all the open source libraries that we discussed. Thanks again for being here and happy coding!
Okay, great. Thank you so much. That was an amazing presentation. We're going to go ahead and we're going to start Q&A. So I'm joined by Arturo, and let's go ahead and start jumping into questions. So our first question is from Tran. How do you recommend handling cross-device testing, especially for those without access to a full range of Roku devices?
Well, hi, thanks for your question. First of all, I would recommend that you make an effort to get the worst device that you can find, and which are probably one of the old Express devices, and then a stick, which would be a mid-range, and if your company has the budget, a Roku TV. That's what I usually use to make sure I have full range of testing. And so yeah, that's it. That would be it in terms of devices. That's what I would recommend.
Okay, awesome. Okay, next question. Performance stuff freaks me out. Any easy wins for making my channel run smooth on older Rokus?
Yeah, well, for that, I think the evergreen advice is to not do things on the render thread. On the presentation, I showed how to create a task and run an asynchronous operation on a separate thread. That doesn't necessarily have to be for things like accessing a remote API or the local registry. You can do any kind of work that doesn't involve rendering. So any calculations, you can do them on a separate thread. So what I would do, an easy win, is to just go to your scene components, to your smaller components, and take out as much logic work as you can from that into a thread. Another important thing there is to minimize the amount of data that you return from the thread to the render set, because that passing on information, it can be also heavy depending on the amount of data that you're trying to pass through. That's what I would say would be an easy win.
Okay, awesome. Thank you. All right, our next question is the promise library, the one that was shown in the demo, is the promise library only for BrighterScript?
No, you can use it without BrighterScript. Actually, since the library is published under RoPM, you can just include it in your project, and it will install a version that is already compiled. The methods that you see me use on BrighterScript are part of a separate set of definitions so that you can use the same syntax as BrighterScript, but by default, the library is already compiled into BrighterScript, so you can use it directly. You will need to use underscores for the namespaces, but it is totally possible.
Okay, great. All right. Next question. For those moving towards more advanced development, how are you integrating CI/CD?
Oh, well, CI/CD is especially hard on Roku because unfortunately we cannot emulate a device like you can do on Android, for example. But there are still some things that you can do in terms of CI/CD. First, the tool I used to create the application called Create Roku App automatically adds node commands to run linting and formatting. You can create, if you use GitHub, for example, you can create a GitHub action that runs those on your pull requests. And the other thing I usually do is usually you only run the static analysis that I show at the end of the presentation from the dashboard when you're uploading your signed package. But Roku also offers a separate, I think it's a Java executable to run the static analysis on your own whenever you want. So I at work I have also created a CI task to run that static analysis on every pull request, which is also very useful.
Okay, awesome. Okay, next question. We got a question from Jeff. Any tips for optimizing performance on older Roku models while still taking advantage of newer hardware capabilities?
Well, all the Roku models. I think if you can, you should, for especially older devices, you should try to minimize the number of animations that you run. I've seen that as a performance boost instead of in terms of usability, like actually going through the application. It moves just faster without animations. And also, one other thing that you can do is to try to not render too much at the same time. If you have a big screen and you can delay rendering some parts of it, maybe just rendering the most critical parts first, and then lazy load any other content, that is also useful. And on top of that, if you are able to, for example, remove from memory or dereference any visual nodes whenever they are not being seen, visually seen. If you can just dereference them when you change screens, for example, that is also a performance boost.
Okay, awesome. All right. Our next question, scene graph components. Use the pre-made ones or build my own. When do you decide to go custom?
Um, I do sort of a hybrid approach, honestly, especially for buttons. I try to use the basic component as much as possible, but sometimes the requirements that my design team asks for are not easy to implement with the native components. And in that case, I still try to stretch it. One interesting that you can do is if you're having a hard time understanding or mapping visually the fields from the documentation for a specific component and their effect on changing them, what you can do is use the scene graph inspector on the left and just play with it, see what changes. So see what can you stretch from the native component before making the leap into making your own. So yeah, that would be my advice. I try to use the native ones as much as possible, but if it's not possible, you always have groups and labels and posters to do whatever you want.
Okay, great. All right. Our next question, debugging. What is your go-to method when print statements just aren't cutting it anymore?
Um, well, just keep trying. Print statements are great, but if you really need that additional insight, uh, again, the debug protocol is amazing. I've seen it evolve a lot in the last year and a half, with the contribution of the open source community and Roku providing the means to doing it. It has evolved greatly, and as I mentioned on the presentation, now you can add a stop statement at any point and inspect what's going on when the application crashes, and it's now really stable. So yeah, go use that. It's a really great tool.
Okay. All right. Next question. Are there any disadvantages to using Brighter Script over Bright Script?
Um, yeah, well, the main disadvantage I think is that it has to compile, and if you have an older computer on a laptop that is constantly overheating like mine, It might take a bit to do that. It can be a bit frustrating that every time you have to launch your application, you need that moment to compile, especially if you're going really hardcore into it and implementing your own compiler plugins, which is something that is possible, but I didn't mention. It can take a bit if you go full into it. That I say would be the main disadvantage. But other things that people might think, which is it's producing more code that it needs, or it's producing code that is unreadable. I've really not seen that. The folks who work directly on the compiler have done a really great job that it is as optimized as possible in terms of the code that it produces. So I say the main thing that bothers me is really that it needs to compile, but it is not that not such a drawback compared to the benefits that it is using the great features that it offers.
Okay, awesome. All right, we got time for a couple more. We should be able to get through these. What plugins are you using to interact with your app in Visual Studio Code?
To interact with my app, like, well, I mostly use the tools that are on the around the debug panel. You know, the everything around the scene graph inspector, the device view, but there are also a lot more sections that I didn't get a chance to talk about. There is a list of commands that you can use to do certain operations on your application. I think the most useful one for me is deleting the local registry, which is usually you have to reinstall the application to wipe that, but you can do it with one click from your VS Code editor. And also something else that is very useful when I don't have a remote at hand, you can press Control K and you can use the arrows, spacebar, enter, and escape to interact with the application as if you were using a remote, which is very useful. I think that that's the main thing, really.
Okay, awesome. Thank you. All right. Question from James. What's the weirdest thing about BrightScript that's made you go, huh, so far?
Um, the weirdest thing, I don't think it's the language's fault. Is maybe a result of some people that are just starting with it and using it in weird ways, which is I see that people, instead of uh, taking another node and calling a function, they assign an observer to a field and change the field that will, as a side effect, run a function instead of running the function directly. I've seen that a bit on my own code base when I joined. That was really weird for me. My go-to there is if you can call the function directly, call the function directly. Leave observers for things that make sense, like implementing some sort of view model. But just using observers to drive behavior that can be a direct call, it's it's nonsense to me, to be honest.
Okay, great. And we've got time for one more question, our last one. What's a function you think is super useful, but not many know about?
A function, I'm guessing you mean a function from the standard library. Something that I use a lot is the raw timespan object. You can do create object and then raw timestamp on quotes, and it allows you to basically have a stopwatch. You can mark a moment and it will start counting milliseconds from there. You can get the total milliseconds from that last call. It's been very useful for me lately because I've been A/B testing features, and when something doesn't go as I expected, it's usually maybe because it's taking too long, and I'm using that to measure that. How long are my operations taking?
Okay, awesome. All right. Well, we are at the end of our time slot for this panel, and that does it for day one of the Roku Developer Summit. Please join us tomorrow for day two. And the links for tomorrow's live stream event on YouTube are going to be available on Roku Developer, rokudev.com, as well as emails that got sent out earlier this week. And you can also just check out the Roku Developer YouTube page. When we go live, it'll automatically refresh with tomorrow's streams. So thank you everybody so much, and I'll see you again tomorrow.